Hello friends, myself R.D. Mahajan presenting my video on Newton-Raphson method. Example, use Newton-Raphson method to solve equation x minus e raised to minus x is equal to 0, correct up to 3 decimal places. And as we require to solve correct up to 3 decimal places, fix your calculus for 3 digits only. By performing this step, mode, fix and then 3 digits, so that the given function is x minus e raised to minus x is equals to 0. We have to obtain the root of this equation by Newton-Raphson method, and therefore to apply this we have to find fx. The left hand side of this equation is that fx, it is x minus e raised to minus x, and differentiating it with respect to x, we get differentiation of x is 1 minus differentiation of e raised to minus x is e raised to minus x into chain rule, differentiation of minus x is minus 1. Therefore that minus and this minus, it becomes plus 1, and therefore we have these two equations, f of x and f dash of x. And then by trial and error method, we have to obtain two values of x which encloses the desired root, and the condition for that is function value must be with opposite sign. Therefore if we consider x as 0, we get f of 0 as, here it is 0 minus e raised to minus 0, it is minus e raised to 0 is 1, and therefore that value is minus 1, which is negative. Therefore we have to find another value with a positive sign for that function value, and therefore consider x is equals to 1, we get f of 1 as 1 minus e raised to minus 1, and if we calculate it by calci, its value 0.632, which is positive. One value with a negative sign, another value with positive sign, means that is root lies between two values, x is equals to 0 and x is equals to 1. And out of these two, we have to consider one of them as initial guess value x0. And remember the step or the technique. Here the function value is minus 1, its distance from origin is 1, and the second value is 0.632, its distance from origin is 0.632. Therefore which is nearest to 0, that value we consider as x0, and therefore we consider x0 as 1. You can consider x0 as 0 also, but it will increase the number of steps or the iterations, and therefore to perform that calculation in less number of iterations or steps, we consider that value of x for which function value is nearest to 0, and therefore with x0 is equals to 1, we go for step number 1. By Newton-Raphson method formula, we have x1 is equals to x0 minus f of x0 by f dash of x0, and then substituting the corresponding values, we get we have x0 as 1, corresponding function value is 0.632 divided by f dash. Therefore to find that f dash of 1, put x is equals to 1 in this, we get 1 plus e raised to minus 1, and if we perform 1.368, and therefore substituting that value here, we get 1.368. It is 1 minus 0.632 divided by 1.368, and by calci its simplified value 0.538, and then we check whether we can call this as root or not by finding the corresponding function value. Therefore f at x1, it is substituting that value here, we get 0.538 minus e raised to minus 0.538 minus 0.046. If it is nearest to 0, we have to stop the iterative procedure, and therefore it is not equals to 0, we have to go to the second step or second iteration, to the step number 2 or iteration number 2, where by Newton-Raphson formula we have x2 is equal to x1 minus f of x1 by f dash of x1, where corresponding values are previous root or the approximation for the root is 0.538 x1, f of x1 is minus 0.046, and f dash of x1, substituting this value of x1 here in this, we get 1 plus e raised minus 0.046 and whole divided by f dash of x1, it is 1.584, and therefore 0.538 minus it becomes plus 0.046 divided by 1.584, and if you perform it by calci, we get that value 0.567 as the new approximation for the root, or x2 is equals to 0.567. Once again we check whether this value we can call as root or not by finding the corresponding function value f of x2 is equals to, substituting that value here in this, we get 0.567 minus e raised to minus 0.567, and therefore if you perform it by calci, we are getting the value as 0.000. As the value of f of x2 is exactly 0.00, we stop the iterative procedure. By Newton-Raphson method, and the steps required or the iterations require only 2. Therefore, as already I have mentioned it in previous example also, Newton-Raphson method is the fast converging. Fast converging means we are getting the required root or desired root in less number of steps, or steps required are less compared with any other method, and therefore x is equal to 0.567 is the required root. One more I will discuss in my next video. Therefore, if you are watching my videos, please like, share it, as well as subscribe to my channel to get notification for my new videos. Thank you.